Solutions for a Year 12 Mechanics mini-test. The two questions in this mini-test consist of question 1 being vectors and question 2 being kinematics in vertical motion. Question 1 in here, we're given a particle. The particle has a position vector, so kind of like as a coordinate with respect to the origin, and it's 4i minus 5j, meaning that is 4 to the right and 5 downwards, 4 and comma minus 5. So as a coordinate would be somewhere in the fourth quadrant, 1, 2, 3, and 4. So it would be in quadrant number 4. Essentially, as a coordinate, will be 4 and minus 5, which gives us this point over there, and there's R as a vector. So it says question part A says sketch R on a diagram showing I and J and the origin O. So label this as the origin O. And perhaps because they specify I and J, I'll write it as 4i minus 5j. So that's part A of the question, sketching out on a diagram. Part B asks us to find the magnitude, which is the length of the line, and also the bearing. So bearing with respect to the north will be the angle from north. So those are the two things the question asks for. Part B, the first thing is the magnitude of R, which is the size of the number. So this length is 4. And that length is 5, will mean that the length of the line will be 4 squared plus, you can call that minus 5 squared, doesn't matter, or 5 squared. It will give you the same result, which in our case is square root of 4 squared, 4 on the outside of the bracket squared, plus negative 5 as a bracket, the whole thing squared. So that's 16 plus 25, which gives us 41. So part B is square root of 41. It's a pure math question, so we don't need to run into any significant figures. The direction as a bearing is the angle that it makes, that it has turned by. But if you look at the mini triangle, we can see that this is 4 here to the right and then 5 downwards. So angle theta, which is the small angle here, which is theta, we can do trigonometry to work it out. So trigonometry to work it out, we can see that we've got an opposite side and we've got an adjacent side. To be honest, we've also got root 41 as the hypotenuse side as well. So it's depending which one you want to do. As long as your calculator is in degree mode, so you can see that at the top of the calculator there's DEG. If not, you need to change it back to degree mode, which is shift and manual. You can see angle to be under degree, so DEG for degree. So either you can do cos inverse to find out 4 divided by root 41. So that's the first way you can find it out. Close bracket on the outside. Alternatively, you can also do like tan inverse of 5 over 4. That will also give you 51 degrees. Alternatively, of course, you can also do sine inverse of 5 divided by root 41, all of which will give us the same angle. In our case, 51.3. So angle theta, I'm just going to put some working out. It's going to be a tan inverse of 5 over 4, which is 51.3 degrees. But the bearing, which is from north, is going to be 90 degrees plus that. So that's 141 degrees as a 3-digit bearing. Part C is that write down the vector that has the same direction as R and 3 times the magnitude. So 3 lots of the vector 4 and minus 5 will be 12 and minus 15. So that's just the part C of the question. Write down the vector that has the same direction as R. So 12 and minus 15 and 3 times the magnitude. So that's question 1. So question 2 here as follows. If I were to read the question, I see that we've got a particle P. Particle itself is projected, first of all, because it's from the ground, everything above the ground, that's your starting point. So your projectile motion, because it says the question is a show that, and we want to find that is 3.6. What we cannot use is we cannot use 3.6 in our survey. So So what that means is if you think about S, U, V, A, and T, S is a question mark. S is not 3.6. That's the first common mistake. Reading the values because it's from horizontal ground and I'm initially going upwards. I'm looking for the maximum point, the top point. So that's one thing you know. The speedometer will go from U equals to 8.4 to right at the top. What do I know about the velocity?
0.
It's 0, and that is a big thing. You need to know that at the top V is 0. So you are not given S's question mark. S is not given to you, but you already know V is 0. And because I am traveling upwards, acceleration is against your direction of movement, assuming that upward is positive. Therefore, A as an acceleration is minus 9.8, or A equals to minus 9.8. Those are the 4 things that's given. You're not required to work out the time. Question with it.
Is this for P or Q?
This is for P. That's for P, part A. Because the S is the whole thing from floor. It's not from someplace else yet. So all we need to do is we need to think of an equation that link V, U, A, and S. Yeah, we did.
In my diagram, it says that when Q is going up, P is going down.
You said that when Q is going up, P is going down.
Yeah.
That's not part A yet. That's part C later on.
I'm gonna do part.
We are still on part A. We're still on part A. What that means is we're looking for the greatest height above the ground. So we need to think of an equation that links S, U, V, and A. So for that part, we're just using V squared minus U squared equals to 2AS. It's a show that question. It doesn't mean we can use the answer. We are finding that out. It's not verify that. If it's verified that, we can use it. If it's show that, we need to use it. Meaning that 0 squared minus 8.4 squared is 2 lots of minus 9.8 times by S. Notice that the 2 negatives in your algebra will cancel out. So what you are left with on your calculator is a simple calculation. That simple calculation would be 8.4 squared divided by 2 lots of 9.8. And if you put in a calculator, we are hopeful that we got 3.6 as the answer. So that's the first part. S equals to 3.6. So a lot of you did a lot of things that's very long. For example, some of you did differentiation somehow. Differentiation of quadratic. Some of you set up a quadratic and you completing the square to find the maximum point. You don't need to do that. You can do that, but you don't need to do that. Because you just need to use the top bit. Because you're given the U, you can set up a quadratic. And then we're looking for the maximum of the quadratic, but we don't need to. Okay? Part B now, what are we doing in part B? The question tells us that the greatest height of a particle Q that's projected from a point 2 meters above the ground. And I'm also projecting things upwards. So the displacement is different now because I need to think about my eye level. If I think about my eye level, my displacement of anything that's above my starting point is positive. Of anything that's below my starting point is negative. That would be if I think about my displacement. However, my velocity, the dip, when it was traveling downwards, even at this point, the velocity will be negative. The velocity at that point is going downwards. After the maximum, as long as you're traveling downwards, even though it is still above your original starting point, velocity is negative. But we're not there yet. We're just at the upward stage. when it's traveling towards the maximum. So again, I'm trying to work out, this time I'm trying to work out U. S-U-V-A-T. U is a question mark. But I'm given S actually, because the question tells me that from a point of 2 meters above the ground, the greatest height is 3.6. So what would be the displacement above your starting point? 1.6. So that's given to you. S is 1.6. What else do we know? Because its greatest height, V equals to 0. Thank you. Greatest height, V equals to 0. Just like the last question, acceleration minus 9.8. So we've got a different equation, but the solution of the equation is U equals to something else. What does U equals to? We will find it out by using V squared minus U squared equals to 2AS. That bit is 0 minus U squared that we want to find out equals to 2 lots of minus 9.8 together with S of 1.6. The negative on both sides conveniently cancel out again, so we can work out the U part. 2 lots of 9.8 times 1.6. The question you ask yourself is, U squared is 31.36. If it's pure math, you've got two answers. U equals to the positive version and U equals to the negative version. You always need to ask yourself this question. Initially, based on our assumption, is Q going upwards 5.6 or is Q going downward 5.6? Initially, does Q go up or down?
Up.
Q go up initially, vertically upwards. So you need to say that I'm not taking minus 5.6 as the answer. The value for U is U equals to 5.6. But those are like your prior thing. Because here, part C is a completely different question. They meet at the same time, at the same height. That is the question. What you are trying to show that is the green part. The green part, you're trying to find two different things. The number of marks is 6 marks. But the criteria is the first comma. Before the first comma, they tell you that the two particles are projected simultaneously, so they traveled for the same time, and after traveling for the same time, they are at the same height. So the particle that is on the floor would have perhaps, actually let's start with the particle that's 2 meters above the floor. 2 meters above the floor, where this is the floor, the particle would have gone up and maybe it had gone down. Why do I know that it had gone down? Because this is what I'm trying to show that. It is at the downward stage. But what we don't know is we don't know if it's above the 2 or below the 2. To be honest, we don't really care. We don't really care, but let's say for conventional reason, I assume that this height is h. Height is an h, which is a scalar number. But in your SUVET, what you fill in is very important. What are you trying to fill in your SUVET is what is going on with particle P and what is going on with particle Q. Because they will meet at the point which is at h meters tall. So what would be the additional height above h if this is the point where they meet? What would be that additional height? If this height is 2, what would be the additional height there? If the whole length is h and this length is 2, what's the remaining length? H minus 2. That h minus 2 is the displacement above the P. P itself would have an S of H minus 2. Could H minus 2 be negative? Yes, it can be. If H is a number that's less than 2, H minus 2 will be negative. What does it mean if H minus 2 is negative? It means that this point is below the starting level of P. Okay? What do I know about U? U is given to you already. Everything else is given. U is 8.4. For the entire journey, U is 8.4. So a lot of you put S to be 3.6. S is only 3.6 at the top, but we are quite sure it's not the top. So S is something that we need to find out. V is not 0. V we don't know. Based on the question, V is something that we're trying to find out. V is the green part. Particles have the same speed. We're finding out their speed. Acceleration is minus 9.8. And T, they meet at the same time, so it's going to be the same little time. Notice that there's two different unknowns that you try to work out. There's no way to work it out using one equation, so we need two equations and two different unknowns. So that's everything we know about P. What is everything we know about Q now? Q has traveled upwards. What's the S for Q? How much has Q traveled?
Isn't it H minus 2?
P is H minus 2. P has traveled H minus 2 upwards only. So P, there's 2 times that P has traveled H minus 2 at that time. But Q would have traveled the entire length. P traveled displacement of that much, which is this much. That's P traveled.
The one that starts from the ground.
But Q is the one that starts from the ground.
Yeah, P starts from the ground.
Oh, sorry, P starts from the ground. I am so sorry. So is that a labeling that I need to change that? So what we've done so far is Q. Apologies. That's Q. Q traveled H minus 2 above. P, on the other hand, traveled the entire journey. So how much has P traveled? H.
You got to change the speed of change.
Oh, I need to change the speed of Q as well. Then Q. The starting speed of Q is, we found it out to be 5.6. Oh, there we go. So Q is H minus 2, and it has a starting speed of 5.6. It went upwards initially, and then it would probably have gone downwards when they met. Whereas P has a bigger speed, biggest starting speed, that U is 8.4. V is again what we need to find out. A is minus 9.8, and T equals to T. The question requires us to find the same height and find the same speed. So eventually, after finding out H and T, we also need to find out V for both particles. How can we find out H first of all? What equation can we set up of H and T with all the rest as unknowns? So we need to go to our formula book. We need to find an equation that link.
I have a question.
Yeah.
How do you know that particles don't meet below 2 meters?
I do not know the particle. I don't know where the particle meet. That's why I put it as H and H minus 2. If H that I find out is a number that's bigger than 2, then they meet above 2 meters. If H as a number that I find out is less than 2, then H minus 2 will be negative. That means that the displacement is negative, but it's still fine. The equation will still work. That's your question, right?
Yeah.
I've got 2 other questions, which is at the back.
No, I was just going to say you have to use S equals U.
I'm just going to say I have to use S equal to UT plus half AT squared. Fantastic.
Put Q twice.
I put Q twice. Oh my god. So the bottom one is P. Thank you. And the top one is Q. Now I try to equate it now. So set up an equation for Q alone is S equals to UT plus half AT squared. So H minus 2 is 5.6T minus 9.8 over 2 T squared. Don't be scared. You have done a lot of quadratic simultaneous equations. This is a quadratic simultaneous equation. Because for your P only, so that's your equation 1. Your equation 2 is H equals to 8.4T minus 4.9T squared. That's your equation 2. And we can clearly see, we can substitute it in and solve. Plug it in and solve. It's not even a quadratic. Why is it not a quadratic? Because the minus 4.9T squared, we can clearly see that it cancels out. So 8.4T minus 4.9T squared minus 2 is 5.6T minus 4.9T squared. I use my highlighter to cross out terms. I don't use a pen to cross out terms because that allows people to see that you have taken that into account. So that in order to solve it, we've got 2 equals 2. So bringing the 2 to the right hand side. On the left, we've got 8.4 minus 5.6. So that's 2.8. So T as a value, we work out T to be about 5 over 7. Or we got it as 0.714. Seconds. Now, because we've got the T value, we can go back and find out an H value. So substitution will allow us to have 8.4x minus 4.9x squared when x is 5 over 7. So typing in a calculator, substitution gives us 3.5. So what is the meaning for 3.5? 3.5 means that
So what did you just say?
I just put it back, put the T into the H equation, and that gives us 3.5. Question on this part at this stage. Terry, question? Okay, I'll double check. Mistake in my marking, right? Yeah, I'll double check. So now, you've got the whole thing as H being 3.5. Is it okay to say that we realize 3.5 is above the 2? So we've just used it to double check that, okay, S is actually positive. But that's just if the question go on and ask, did they meet above or below 2? That's what you answer. But that's not the full question yet. The question asks us the following. The particles have the same speed and are moving in opposite direction. So what it means is we need to go on and find out the speed. So each one, you can easily find it out because we've got U, V, A, and T. I prefer to do V, U, A, and T. Why do I prefer to do that? Because it's a linear equation. There's no quadratic to think about. So I'm going to use V, U, A, T for both particles. For Q, V equals U plus AT. V equals to 5.6 minus 9.8 lots of 5 over 7. For P, V equals U plus AT as well. But your V is 8.4 minus 9.8 lots of 5 over 7. And if we have done our time correctly, when we do our substitution, so starting with 5.6 minus 9.8 lots of x, we should get minus 1.4. So minus 1.4 means it's traveling downwards at that stage. Negative 1.4 as a velocity. And at the same time, 8.4 minus 9.8 lots of x give us positive 1.4, meaning that it's traveling upwards. So this means that this is downwards, and 1.4 means it's upwards. So we have shown that the particle have the same speed. The speed, they are both 1.4, but they're moving in opposite directions. So same speed, (1.4 ms minus 1), but opposite directions. Questions? Yes.
From the beginning,
From the beginning?
Yeah, I'm just quite confused as how you got distance. Like you said h and h minus 2.
I said h and h minus 2 from the beginning. So you need to, because we don't know where they meet, you need to have an assumption.
Yeah.
It depends what you assume. You can assume the gain in distance to be x. If I assume this to be x, then that distance is 2, will give you the whole thing as 2 plus x. As long as you have some form of assumption. Because I don't know where they meet, I assume the height to be h. I assume the whole height from this point to that point to be h. Therefore, the gap in the middle is h minus 2. Because one particle started 2 meters above. So you would have gained certain thing. And this certain thing is more than 2. It's my assumption. Remember, what we found out is this height is 3.5. That means that this height here is 2, and the remaining height is 1.5. So we find out that it's 3.5. But depending on what you assumed, you could have assumed the distance that you're trying to find out to be x. Then x would be 1.5. And 2 plus x will be 3.5.
How do you know there's a gap?
How do I know there's a gap? Because I don't know. I could find out h to be 2. If I find out h to be 2, that means that there's no gap in between.
Yeah.
But I still need to assume that there is a distance and then find that distance out. Okay. All right. Let's stop this one here.